We are ready for the chain rule, and the chain rule is a differentiation rule that deals with composite functions. So it allows us to do a lot more, or gives us a lot more versatility when we're doing derivatives. And the way it works is, if we take a look at some of these functions here, the differentiation rule, where we're going to use the chain rule, is going to be on the problems on the right side. The ones on the left we can do without the chain rule. So if I take the x squared plus 1 and I raise it to a power or take the square root of it or something, now I have a function inside of a function. So this is where we would use the chain rule. Okay, this one here we wouldn't need the chain rule, so the derivative of this is 1. But here, now the x plus 1 is embedded inside another function, and that function is just x to the negative 1/2. So this is when we are going to use them. So on these functions over here. All right, let's take a look at what the rule looks like. So when you apply the chain rule then, so the g of x is our inside function. It says you're going to take the derivative of the outside function with the g of x inside there. That doesn't change. And then you're going to multiply it by the derivative of the inside function. All right, another way to think of this is, let's say that the outside function is the function, we'll just give it another variable, let's say f of u, and then let's say the inside function, the u, is equal to the g of x. So when I do the derivative of y is equal to f of u, I get dy du. And when I do this derivative here, I get du dx. So the thought is, if we multiply these two together, then the du's will cancel. So that one then will give us the derivative that we need. All right, so let's see how it works here on this problem. So you see that I have an inside function. The inside function is the x plus 1. So it's what's in the denominator. Okay, so that means then the outside function is y is equal to 1 over u. So to do the derivative then, we could do the derivative of this first one. So this here, to do this derivative, is going to be du dx. And that is equal to 1. Here, dy du. Well, to differentiate this one, yes, you could use the quotient rule, but more than likely we would just rewrite it as u to the negative 1. So then we'd get negative 1 u to the negative 2, or negative 1 over u squared. So then the derivative is going to be the product of these two, so 1 times. But I don't want the u in there, I want the x. So I have to replace the u with what it's equal to. And right up here, we said that the u is 1 over x. I'm sorry, that the u is x plus 1. So I get negative 1 over x plus 1 squared. Okay. What I'm going to do now is take this one here, and I'm just going to rewrite it. So we're going to look at it like this. Y is equal to the x plus 1 raised to the negative 1. Okay. So kind of going through what I did here very technically, and you won't have to go to all this work, so let's just look at how it works if we remember the rule. It said take the derivative of the outside function with the x plus 1 staying the same in there. So the outside function is like having u raised to the negative 1, right? Which is what we had over here. Okay, so to do this derivative, we bring negative 1 out to the front, and the x plus 1 then is raised to 1 less power. And then we take it times the derivative of the inside function. and the derivative of the inside function is just 1. So when I simplify this, I get negative 1 over x plus 1 squared. And notice that's what I had over here. Okay, so that's the chain rule. All right, let's do some more examples. All right, so here I'm showing you how you can split it up. So your inside function is what's underneath the radical. So 3x squared minus x plus 1. So we can let that equal u. And then if I replace that 3x squared minus x plus 1 with the u, my outside function then is the square root of u. All right, doing this derivative, the derivative of u with respect to x, we get 6x minus 1. Doing the derivative here, I would first rewrite it as u to the 1/2. And then when I do the derivative, we use the simple power rule. So 1/2 u to the negative half. And actually I'm going to rewrite this as dy du instead of the prime there. All right, so now when we multiply these then together, then the du like cancels out, so we have 6x minus 1 times 1/2 u to the negative 1/2. The only thing is we want dy dx, so that's what we're looking for when we do the derivative. So that means we cannot have a u in the expression, so we have to take out the u and replace it with what we originally set it equal to. So we would, most everything is going to look the same, so our u then is 3x squared minus x plus 1 to the negative half. And if we wrote that as a fraction, the 6x minus 1 would be in the numerator, the 2, and the 3x squared minus x plus 1 is raised to the positive 1/2, so it would be the square root of the 3x squared minus x plus 1. Okay, now that's kind of the technical way to do it. We're hoping that you get to the point where you can just keep it all in there, not substitute in the u, but write it like this. And then you think of, I'm going to first of all find the derivative of the outside function. So to get the derivative then, well, this is still y here. Now I'm going to do the derivative. I bring the exponent out to the front. I keep this exactly the same, 3x squared minus x plus 1. It is raised to 1 less power, and then I take it times the derivative of the inside function, which would be 6x minus 1. And if you look at those two, if you do a little bit of algebra, you can see that these two are the same thing. Okay, let's try it with this one then. This one, we're not going to substitute in the u for the inside function. We're just going to see that the outside function is like a quantity raised to the 3rd power. Okay, come on, get rid of that. There we go. So this quantity is staying the same. We're just thinking of it as being like some variable raised to the 3rd. So first thing we're going to do is find the derivative of that outside function. So if it were like x to the 3rd or u to the 3rd, we'd bring the 3 out to the front. We're going to keep the x squared plus 1 the same. It's going to be to 1 less power, you know, applying that simple power. But then for the chain rule, because now we have an inside function, we now follow it up by taking the derivative of the x squared plus 1. And then we will just simplify it. 3 times 2x times x squared plus 1 quantity squared. And no, you don't have to multiply that out. Okay. Let's take a look at this one. So let's rewrite it first of all. So we've got y. I'm going to get rid of that cube root of 3 and write it as a power. And that power would be 1/3. And we have a power to a power, so we'll simplify yet then. So we get x squared plus 4 raised to the 2/3. Okay, that looks pretty good. So I can clearly see the inside and the outside function. So the inside is the x squared plus 4. So to get the derivative then, we bring the exponent out to the front. The x squared plus 4 is to 1 less power. And then we do the derivative of the inside function. Okay, so then when we clean this up, the 3 and the x squared plus 4 is going to move down to the denominator. So the 2 times the 2x stays in the numerator, so we get 4x over 3 times, and it's a cube root, it's raised to the 1/3, so let's do the cube root of x squared plus 4. And yes, you could show it as a rational exponent. Alright. So finding the derivative of a quotient then, so I showed you one similar to this, so probably what I would do on this one is rewrite it first of all by bringing that x squared plus 1 up to the numerator. So that whole quantity is going to be raised to the -1. And then I'm going to do the chain rule, so the x squared plus 1 is the inside function. So to get the derivative then, the 3 stays there, the constant multiple rule, right? I'm going to take the 3 times the -1, so that's going to give us a -3. The x squared plus 1 will be raised to 1 less power, and then we have to multiply it times the derivative of the inside function. So when we clean up, we get -6x over x squared plus 1 quantity squared. And yes, you could also do the quotient rule on that, and you would get the same thing. Okay, so that would be another way you could do it. I could also use this one though and do the chain rule. So you're going to have options, you just kind of have to figure out what's going to work best for you. Okay, so a quotient raised to a power. Okay, now this one's going to get a little more interesting. My inside function is a quotient itself. Then I have the outside function where I have that whole thing squared. So to do the derivative then, the first step is to look at the outside function. So I bring the 2 out to the front, and then the whole quotient is still there, but it is raised to 1 less power. So it's just raised to the first power. Now I have to take it times the derivative of the inside function. And my inside function is a quotient. So now I'm going to have to do the derivative of a quotient. So we're going to use the quotient rule, which says you take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So to get the derivative of the inside function, we had to apply the product rule. All right, so now we're just combining all of these. So on top then, like let me see, get the red. So I'm going to simplify this. Okay, so distribute the 3x squared plus 9 minus 6x squared plus 2x. So that'll give us negative 3x squared plus 2x plus 9. So that's a factor in the numerator. That needs to be multiplied by this numerator. And then also I have a 2 that'll be in the numerator of my answer. And in the denominator, I have an x squared plus 3 squared here, and then I have it times another x squared plus 3. So I actually have 3 factors of x squared plus 3. So that would be our answer. Okay, so you can see it's going to get interesting, and there's lots of ways that you can do these, and so you just kind of have to figure out a way that's going to work for you. All right, good luck with the chain rule. See you in class.